Hello and welcome to this video, which is about amortization of a loan. So deriving the formula, which is on page 31 of your formula book. In this formula we use the letter P to denote the principal, which is the original amount borrowed. A is the amount to be repaid at the end of each equal time period. And T is the total number of payments to be made. So for example, if you borrowed an amount to buy a house with, for a mortgage, you would have the P being the amount that you originally borrowed. A is the amount of payments that you have to make each month, for instance. So every single month you would have to pay back the amount A towards paying off your mortgage. And T would be the total number of months that you have to keep this up for. So T is the total number of payments that you would have to make over the term of your mortgage. In the diagram here, the timeline, we can see currently it's time 0. And then each one time period represents one of these equal time periods that we are discussing. So in the mortgage example, this is the end of the first month, the end of the second month, the end of the third month, all the way up to the end of the 10th month. And you are required to make a payment to the bank of an amount A in each of those months, and the payment is made at the end of the month. So there is no payment at time 0. The first payment is due at the end of the first month. So to figure out how much needs to be paid each month, we need to find the present value of each of these amounts. And what we need to do is equate that present value to the principal amount that we started with. So present value is dependent on some interest rate I. If we take the first value back to present day, it will be A divided by 1 plus I. We become its value, it's discounted back 1 month. If we discount the second value back to the start, to today, it will be A over 1 plus I to be squared, so it's been discounted for 2 months, and we continue to do this for each of the payments. So the third payment will become A discounted for 3 months, A over 1 plus I to the power of 3, and so on. Our final payment, brought all the way back to today, will be A over 1 plus I discounted for T time periods. So what we need to do is add up the current value of all of those, or the present value of all of those payments, and equate it to the present value of the loan, which is P, because we're taking out the loan today. So we come up with this equation where we say each of those payments, all added together, balances with our principal. So we can see here the A is a common term, so we can factorize it out. And we have this equation. So A is 1 over 1 plus I plus 1 over 1 plus I squared, and A multiplies by this whole series, and that is balancing with P. So it is a geometric series, and there's our formula for the sum of a geometric series. The first term of our series is 1 over 1 plus I. And our common ratio is also 1 over 1 plus I. Because each term is multiplied by 1 over 1 plus I till we come to the final term. N in this case is T because we have T terms. So when we plug these values into this formula using T instead of N, we come up with the final formula down here. So what we need to do is simplify this formula a slight bit by taking common denominators. So a common denominator down here will be 1 plus I, and a common denominator within the bracket up here will be 1 plus I to the power of T. And once we've done the common denominators, we realize that the 1 over 1 plus I in the numerator will cancel with the 1 over 1 plus I in the denominator. And also in the denominator, we have a 1 cancelling with a minus 1. So the simplified version becomes this formula, A on 1 plus I to the power of T minus 1 over I on 1 plus I to the power of T. And all of that balances with our principal. Now we need to rearrange this formula so that we have A equals, it's the amortization amount that we're looking for. So we're rearranging it to have A equals. So we need to multiply both sides of the equation by I. so I will move to the numerator on the other side of the equation. The 1 plus I to the power of t will also move to the numerator on the other side of the equation. And the square brackets up here, 1 plus I to the power of t minus 1, those square brackets will divide both sides, so it'll be the denominator on the far side of the bracket of the equal sign. So once we've rearranged our formula, we're pretty much done. The last thing to do is to put it into the format which is in the formula book, which is bringing the p out in front of the fraction and also removing the square brackets from the denominator.